So this is the first of two videos on finding an inverse function. And as you can see here, I have a mapping diagram, and I've got my domain here, or the set of all possible inputs for the function, and the range here, the set of all possible outputs. And to get from the domain to the range, to get from the inputs to the outputs, then you should be able to see pretty easily that all I'm having to do is add 3 every single time. So this particular function, f of x, is equal to x plus 3. Because if we took x, then that would map to x plus 3. Now, what's the inverse of this function? How do we go back? So here you can see I've got what's the inverse of f of x equals x plus 3. And you can see that the arrows are actually going back now. Okay. Now, just to introduce some notation, if we have f of x and we want to know what the inverse is, we denote the inverse of a function as f to the minus 1 of x. So we're now trying to find f to the minus 1 of x. It's interesting to note that before, this was our domain, whereas now this is actually our range. Okay, so the domain of f of x is actually the same as the range of f to the minus 1x. And before, this was our range of the function f of x, and the range of f of x is the same as the domain of f to the minus 1x. So how do we get from the domain of f to the minus 1x to the range of f to the minus 1x? Well, of course, we're going to do the inverse operation. Before, to get from here to here, we added 3. So to go back, we're simply going to take away 3. 5 take away 3 is 2, 12 take away 3 is 9. So if we had x, then that would map to x minus 3. So for this function f of x equals x plus 3, the inverse function, f to the minus 1x, is equal to x minus 3. So f to the minus 1 of 5 is 5 minus 3, which is 2. F to the minus 1 of 6 is 6 minus 3, which is 3. And if we think about what we had before, we had f of 2 plus 3 equaling 5, and f of 3 plus 3 equaling 6. So you can see that with the function, the original function, and our inverse function, these numbers simply swap around. So our coordinate for this particular function would be 2, 5, but for the inverse function, the corresponding coordinate would be 5, 2. And the coordinate for this function would be 3, 6. Corresponding coordinate for the inverse function would be 6, 3. So if I go into GeoGebra now, then we can see these functions geometrically. This is the function f of x equals x plus 3, and this is the inverse function f of x equals x minus 3. And if we try and look to see what the relationship is between these, then we can look at the points as well. We can look at each point and look at the corresponding point on the inverse function. So here's our original function, and if I have a let's start with a nice whole number here. So I'll just move this to a nice whole number. Why isn't that moving? That's strange. Or maybe I need to move this one. I'll move this one instead. Right, there we go. So if I move this to a nice whole number, try and get on. So for the function, f of 1 is equal to 4. So you can see that our input is 1 and our output is 4. And for the inverse function, f of 4 is 1. So what's actually happened here is this function, f of x equals x plus 3, is actually a reflection in the line y equals x. Okay, so to get the inverse function of a function, you simply have to reflect it in the line y equals x. And you can see how all the points have been reflected there in the line y equals x. So there's a quick introduction to inverse functions. Please go on to the next video for a slightly more detailed analysis. Thanks a lot. Bye.